Problem number 6. What force is required to accelerate a sled weighing 125 newtons at 44.44 meters per second square? So we build the table as we are reading the story. The force is what the problem is looking for. The acceleration is 4.44 meters per second square. When it's being pulled by this force here, is going to accelerate, which means that it's going to change velocity over time. So now we have two forces here. One is the pull force, the other one is the weight. So both of them, they have very similar, actually it's about the same formula in terms of force, mass, and acceleration. The applied force or the pull force is mass times acceleration, but this mass must be in kilos. The weight is Fg is equal mg, so the mass must be in kilos as well. And g is the acceleration of gravity, which is 9.8 meters per second square. So we have those two formulas that we need to work and find a solution for this problem. So we know that Fg is the weight of the sled. And the formula for Fg is m times g. So my weight was given in the problem 125 newtons. The mass is the one that we are looking for. So we are using this formula to calculate the mass in kilos, and then we are going to replace the mass on this formula to find the force that we cause this acceleration. So this acceleration here is acceleration due the motion that is on a surface. And this acceleration is the motion to the gravity being applied or pressing on a mass. So this is not a falling object, it is an object on a surface, but still we have the influence of the gravity, and we have to take this in consideration. So now that we found the mass, now we need to do our substitution. The mass is 12.75 kilos times, now this is the acceleration was given the problem, 4.44 meters per second square. When you multiply both numbers, we have 56.6 Newton. So that's the force that is going to produce this type of acceleration, which means that the sled is going to change speed over time. Problem number 7. Now, in this problem, we are going to combine second Newton's law with the acceleration formula, which is the change in velocity over time. Change in velocity means the final velocity minus initial velocity during this interval of time. So this is an example that we can apply those two, that combine those two formulas. So let's read. Joe and his skateboard have a mass of 85 kilos, and he is skateboarding along at 7.89 meters per second. So this is velocity. So here was given the mass of Joe plus a skateboard, because both bodies they are combined, that is going to create all these impact. So the mass is 85 kilos. Is coming along with this initial velocity, 7.89 meters per second. So when a wheel falls off and he grinds to a bloody halt in 2.01 seconds. So 0.2, that's the interval of time that when he was coming with that speed and he fell and he was stopped by the pavement. So the pavement was producing a stopping force or a friction force that is opposing the motion. So that's why we are representing with in this direction. He was coming this direction, and the pavement was applying a opposed motion or force on his face. So what it's asking is, what is the value of this force? Okay, so since we have here our initial velocity, we have to have our final velocity in order to use acceleration, because acceleration is changing velocity over time. So we need to find the both velocities. One is the one that he was coming. The second one is when he stopped for this interval of time. He stopped, so he comes and he hits the ground. So the whole thing take about 2.01 seconds. So he's asking, what is the force that the pavement is producing to stop this? So again, we are going to use the second Newton's law, F is equal to ma. Now A is, we don't have here, was not provided, but was provided change in velocity. So the change in velocity is final minus initial. Our final velocity here is 0, and the initial is 7.89, so over the time. So that will be 0. So we have now, you have, actually this is 85 times a negative 7.89 over 2.01. So what you're doing here is you get your calculator, and you can solve this fraction first. 7.89 divided by 2.01 times 85. So we have 336.65 negative. So that's why I explain why this force ended up being negative, because it's opposing the motion. Newton's law of motion, problem number 8. Erica thumps a stationary soccer ball with a force of 86.5 newtons. I'm already kind of filling the table as I read the problem. So you draw a table and start to fill with the information. And her follow-through keeps contact with the ball for 0.86 seconds. So another piece of data information. With what velocity does the 0.774 kilos ball leave her mighty foot? So this diagram kind of represents the story. So that is the foot, and that's the ball. So it's going, the player is going to kick the ball. So the ball is stationary. The problem said the ball was stationary. So the VI is 0. The initial velocity is 0. And the problem is asking, what is the final velocity, or the velocity that left her foot? So that's what we are looking for. So the time interval here, from the time that she hit the ball and left the ground, that is, I'm sorry, let me repeat again. The time she hit the ball and the time the ball left her foot, that is the almost 0.8, almost 0.9 seconds. So what we are going to do in this problem is we are going to use Newton's second law, and we are going to use the acceleration formula in this equation. We don't have acceleration, but you have a way to calculate. So we can calculate separately, or you can just do the replacement here in the formula. Either way will work. Okay, so what was given? The force, 86.5, the mass of the ball, 0.774, and the final velocity is the velocity that we are looking for. The initial velocity is 0, and that's the time interval that all this happened. And then we are going to do our substitution. Now, here is 0, and now we have this number divided by this number, right? So we divide both numbers, and is 0.9, and then we divide both terms by 0.9, and our final velocity is 96.11 meters per second.